Hi, my name is Kojo, and today I will be talking about the ADXL202 duty cycle modulated accelerometer by analog devices. And basically what that means is that you have this G-force sensor that, depending on how you tilt it, modulates the duty cycle of an output signal. So if it was to be flat, the on time, T1, versus the period, T2, would be equal to 50%, giving you that 50% duty cycle. If it was to be slightly tilted, then the signal would be having a duty cycle of slightly less than 50%, slightly more than 50%, and what have you. So how do we go about using this? Well, what I did was to use the MSP430 by Texas Instruments, but it's just a microcontroller. You can easily use an Arduino, you can use a PIC chip, or whichever microcontroller you prefer. And it has this internal function called timer A. And what timer A does is it can generate an oscillating signal. It can vary the duty cycle and all of that. But for our application, all we need is a general 50% duty cycle clock oscillating signal, oscillating at 100 times the frequency of the ADXL202. And the reason for the 100 times is to capture the percentages directly. And how we go about capturing the percentages is via an interrupt service routine within the MSP430. So anytime it sees a rising edge, it starts capturing the data, or it starts capturing the time for which the signal is on. And anytime it sees a falling edge, it starts capturing the time for which the signal is off. So in my program, I refer to this as T3. That makes the duty cycle equal to T1 over T1 plus T3. And so I use the interrupt service routine to go about doing this. As for the hardware side of things, there is a pin on the ADXL202 called T2, and this is what determines the period. It's connected to a resistor called Rset, which, when varied, varies the period of the duty cycle modulated signal. How this happens is via the relationship T2 is equal to R set over 125 mega ohms. So that means that if R set were to be 125 kilo ohms, then the period induced from that would be 1 millisecond, giving you a frequency of 1 kilohertz. Other than that, there are some pins connected to some filter capacitors, one for the X direction of tilt and one for the Y direction of tilts. This is to ensure that you get the cleanest signal possible out. Then you have the actual duty cycle modulated signal. And this is output into the MSP430, where the interrupt service routine compares the on time to the off time and therefore calculates the duty cycle. Also input is an oscillator at 100 times the frequency of the ADXL202's output. After this is done, this is output to a decoder. This is to simply save on the number of pins required to be output directly from the microcontroller. Also, it can be output to an LED driver. In this case, I use the CD4028. And after it's output to the decoder/LED driver, it's output to the LEDs. And 6 LEDs were used to determine the intensity of tilt of the module. And then you have a really cool toy you can play with. Possible applications include that of a normal accelerometer. So this can be used in airplanes for detecting how far tilted the jet is. This can be used in level surface correction to make sure something's absolutely flat. Or it could be used to make a simple toy, as I've demonstrated with the LEDs. All right. This was the general overview of the ADXL202. I hope you've enjoyed it.
Cut, edit, whatever.
And cut. Actually, and edit. I'm really gonna figure something. It could be used for.
You could actually just film it in action and then do a voiceover over it. And then cut out that last 10 seconds.
So, filters, got X output.
Still filming, by the way.
Oh yeah. Just going to the bloopers. Level surface. 2 shake. 3 shake.
Let's try and find out in the past half a minute.
Nice. What was it called?
Debbie Down.
Nice. Alright. Possible applications include having this installed in
I'm just gonna do this every time now.
It happens every time. No. This was the general overview of the ADXL202. I hope you've enjoyed it.